Okay, guys, good afternoon all, and I welcome you to this webinar about machine learning and Python. Okay, my name is Amritansh. 1 minute, let me just share my screen here and we'll get started. First of all, you all can hear me, right? Yeah, guys, if any one of you is having any problem in understanding or listening to me, please let me know. Okay. All right, very good. Now, today I'm going to talk about the basics first, okay? And I will also kind of like to stress on the importance of Python. Okay, why Python is the language that maybe we should look into, or I will be personally looking into. Okay. So first of all, I would like to know how many people have heard this term called machine learning? Just you can reply in the chat as well. You do not have to answer. So just in the chat, can you let me know how many people have heard about this term called machine learning? Anyone? Like, no one has heard machine learning as ever mentioned in news media, newspapers? Okay, Ibrahim says he has heard of it. Good, good. Anyone else? Okay, all right. So some people have definitely heard about it. Okay, all right. So guys, today we are gonna kind of make some progress here and we'll try to understand. So first, let me tell you about myself. Primarily, I'm a founder and AI researcher at Neurodynamic AI. Okay, and in this scenario, I have been working within this is my own startup. So we have been working over 4 years now, as a matter of fact. We started in 2018, around in month of July. So it has been more than 4 years as of now. So we had a product called Deep Interview, which we ended up selling in the month of February, March. And right now I'm working on a new product idea. But in same time, I also like to do AI research and like to educate and mentor people into AI or the field of AI and how to. Sorry. Okay, so unless you are not directly talking to me, please you will mute yourself, okay? Because there could be a lot of other audios which can be distracting. So as I was saying that it would really be helpful and it would be nice that if you guys all can kind of mute your mics unless you have to speak, or if I ask you a question, then you can unmute yourself. Okay, all right, very good. So this is what we are gonna do, and this is how we are gonna proceed here. Okay. Anyways, so I have been working in the field for over now 5 years, as a matter of fact, my personally, okay. And this year I have been focused more on the product development around artificial intelligence, and also kind of merging the ideas with blockchain as well. All right. So we need to definitely think about it, and let's try to understand what we are really talking about and why is it important. Okay, but first of all, I think I should have shown this clip for earlier. If you are attending online and you will be muted, and please do not unmute yourself automatically. If unless some question has not been asked, don't do it. Okay. Now we are encouraging everyone to keep the sessions interactive. And you can ping me through the chat itself if audio or video is not working for you. And don't worry, you will not be able to understand everything. That's not the intention here anyways. We are trying to give a good idea that what is going to happen in world of machine learning. Okay, so that is something that we are interested in, and we will explain you how to get around with it. Okay. All right. Now, there could be different inspiration why you might be here, and maybe You want to learn something new today, okay? Or you have the curiosity about this field in general, okay? So that definitely could be a good idea that would be interesting for people to learn and know more things about it. Or you want to expand your horizons here, that you want to know or to think about different technologies and try to understand how all of these works. Okay, and it's relevant to acquiring skills for data science job, of course. So that's why maybe you're looking for projects to work into the world of machine learning, or maybe you're looking for mentors and educators in this space, or you want to get hands-on training. Whatever might be your reasonings here, you all are welcome in this seminar, first of all. Okay, and I hope we will have a good time learning concepts together. Okay. Okay. So guys, now in these discussions, we always have these different discussions that keep on happening. And many times there is a lot of confusion. Okay, that there are just terminologies that are really confusing for people. And so a lot of words get thrown around, right? Artificial intelligence, machine learning, maybe deep learning, maybe data science, right? A lot of these technologies are kind of thrown around and people do not know what they are talking about. So let me first debunk or kind of put some light on these different topics. Okay. So if we think about artificial intelligence, what is inherently artificial intelligence? Its ability to sense, reason, engage, and learn in the way humans do. So guys, how would you define intelligence? Before I go for artificial intelligence, if I were to ask you, how would you define intelligence itself? And I would like that if you guys could write your answers. I would really like that. If you could write down your answers in the chat, and I will read it out for all of you. Okay. So anyone who is interested, please go ahead. Okay, let's have a look. Ibrahim says the ability to create ideas, process instruction, and other things. Okay, okay, all right. Okay. So I would like to say intelligence is this general ability that we have. Intelligence is this general ability that we have, that we are utilizing, or that's how we kind of utilize and the way we adopt to our different scenarios, okay, or different environments, the way we solve our problems, okay, the way we learn new concepts, okay. But when I say learn, it does not mean just to memorize, to really learn these concepts. That's what we are really talking about. Okay. So artificial intelligence would be a very good idea where we would try to artificially, or we will try to emulate certain algorithms or certain methodologies which could utilize all this. Okay. And this is something gonna be really, really interesting. How do we do it? Now, understand, till this day, there has been no true artificial intelligence that has been really developed. Abhiram says, able to mimic biological human brain and create a network of actions and able to produce innovative ideas. Yes, that's actually very good. So all of these ideas are definitely interesting to us, and we want to kind of work in these things, and we want to see that how to work with artificial intelligence. Now you have to understand that artificial intelligence, as a matter of fact, is still a very unsolved problem. The true artificial intelligence, if we have to talk about. Okay, the true artificial intelligence is definitely very something that we have not been able to realize yet. But what we are able to do right now is we are able to come up with some simple constructs where we are able to solve problems which are very particularly defined right now. Let's say you want to figure out attrition in a company, okay, or you want to predict house pricing, okay, or you may want to detect the image in the or the object in the image. Very specific problems, and that kind of intelligence, artificial intelligence, is called narrow artificial intelligence. So this is what we are really interested in. Similarly, whatever we will run right now with machine learning and everything, this is what we are going to realize, and this is how it's going to work. Okay. So that's the general field of artificial intelligence. Now, this field is pretty big. You have to understand this. There are a lot of fields and subfields that we are working, like computer vision, robotics, natural language processing, voice recognition, planning and optimization, knowledge capture. Okay, the fundamental ideas of neurobiology, psychology can also be involved in. Now, of course, I'm not gonna be kind of pushing into the direction of AI right now. That will not be our task. That is not where we are intending to go immediately. But eventually, that is where all the pursuits are fundamentally. Now, a very specific field of artificial intelligence is called machine learning, where we learn, where we learn from data. So guys, could you give me some examples where we learn from data? Like, or can you give me some examples in your own life where you learn from data or using the data itself? Any idea? Like, what do you do in your life where, yeah, Dan says how much I spend in a work in a month, or how long I have to travel with. Yeah, and many times, like let's say you move on to a new city, let's say you get a new job, you get a new home, or you get a new place, right? From that place, you try to travel every day to your office. And it might take some trials, some drives to figure out how much time in different times you'll be able to figure it out. Okay. So that is what's gonna happen, and that's gonna be really interesting. And similarly, maybe based on the data itself, maybe you will decide on which day or more shopping discounts are on which day, right? Or which time of the month they give you more shopping discount. That can also be figured out using utilizing just the data itself. Okay. So all of that can be really, really impressive. Okay. So this is something that we will love to know and we will like to understand at the end of the day. All right. So this is gonna be really, really interesting, and we will see that how do we do this. So understand machine learning is a type of artificial intelligence or a subdomain of artificial intelligence where we are treating algorithms alongside with the data or the experiences that we get at the end of. Okay, and they give us our outcome. Whose mic is on? Hey guys, keep your mic muted here, please. Okay, otherwise there is always a lot of background audio and we get. Okay. So particularly, we are going to think about machine learning far more than other of them. But let's try to define machine learning inherently. That is going to be important for us. Okay, so let's define learning first of all before we jump onto machine learning. Okay, so learning is any process by which a system improves performance from its past experiences. A very famous statistician, Herbert Simon, gave us this definition. And I think this is amazing. Okay, how do we know we are learning anything? How do we know that we are learning anything, as a matter of fact, in nature? This is okay, so learning would be like where, let's say you can talk about any system, artificial system or natural system or humans as well. So guys, how did you know? Let's say you try to learn something. Let's say you try to learn something. How do you know you have learned that topic or learned that concept? Let's say you started driving. How did you know, or how did you learn to drive? By not committing the same mistake or wrong step. Okay, good, good. But how did you measure that you're not creating the wrong step? There could be infinite wrong steps, right? Yeah, taking another route with better results. So the overall idea is fundamentally what we like to look at here is, and this is interesting. Okay. Okay. Now what's gonna happen here is, and this is something that you have to think. Now, different ideas can be floated around here, but the idea is, as you will practice, you will need to understand that you are creating less mistakes. So you will have to define some parameters, of course, some parameters. Okay. And based on that, these parameters, what you decide at the end of the day is, at the end of the day, what do you decide is, let's say we want to utilize this one and we want to work here and we want to not commit the same mistake or learn from experience. So basic idea is we learn from experience. Okay. And as we learn from experience, we get to, or we understand that we are creating less mistakes, or our answer is far more optimized. Okay. So if we talk about the drive itself, if we think about it, as we travel daily through the traffic itself, what we realize is our routes or our selection or our timing selection becomes far better. Okay. And we are very optimized. We know how much time it would take from us to start from our home to office and then maybe office back to home, and what are the best ways and routes to select at the end of the day. Now, similarly, if I wanted to translate this idea, okay, similarly, if I want to translate this idea around in machine learning, okay, I could simply say this, that machine learning corresponds to computer programs or algorithms which improve their performance through experience without being explicitly programmed. And this is very important term. This is very, very important term for us, that without being explicitly programmed, we would like to kind of teach the machine through the data and the experiences that we are getting. So now, why is this even necessary? Why we are talking about all this? What would be the plan here? So why we want to do all this is, we want to develop systems which can automatically adapt and customize themselves. Okay. We want to develop systems which can automatically adapt and customize themselves, because our world is ever changing. You have to understand. If you start hard coding for every scenario, that won't work for us. Okay. So what if we could figure out the function? Okay, what if we could figure out the function that might be governing the data distribution? Now, we also want to discover new knowledge from large data sets, and we are continuously creating new data. So if I guess, I ask all of you, like, how much data do you think you create, or how much data do you have, like, on your mobile devices or using all your electronics devices? How much data are you creating every day? No, personally, I'm not talking as a civilization. I understand as a civilization, we must be creating petabytes or exabytes of data every day. Personally, I'm just asking, personally, how much data do you think you end up creating? I know it will be different for every person, but I'm just simply saying that. Any idea? Like, data could be in multiple forms, guys. Photos are one sources of data. Okay, then says 100 to 500 MB. Okay, that seems reasonable. Anyone else? Like I want some quantification either in MBs, KBs. What do you think? How much data are you creating every day? At your work, at your home, like when you consume or when you create new photos, upload these photos on social media, right? You make videos, upload them on, let's say, TikTok or something, some equivalent app, right? And do something like this. Then what's going to happen over there? So according to me, at least if I were to think about my data itself. So I do use a lot of internet every day for my work, and I create, let's say, code, and I program things, attach these ideas, put these ideas online, right? Sometimes I also often use social media. So these data points could be ranging from KBs, but for most people, it is definitely in MBs. And at some time, depending how much, let's say I'm uploading few videos today. Let's say this Zoom video that we are creating, right? Within, let's say we are having 2 hours webinar, right? Very conveniently, I can tell you that 300 to 400 MB of recording would be created immediately without any fault. Okay. And 400 MB data is just created in 2 hours of a video session. We can create pictures, we can take pictures, and we can do a lot of different things. And you will see that we end up creating data. Even in your user data that you are creating, that is recorded, okay, like in JSON format, that will definitely work. So Karan says 1 GB a student, okay. Dan says, I don't make videos often, even it could be of 5 GBs. Yeah, it could be, like, depends. Like if you start shooting something in 4K, that would be massive. 4K videos take massive amount of size, and you will require a lot of compute power and lot of storage. So if you have such humongous data, it's not going to work out anyways. Okay, it's not going to work out anyways if we have such massive amounts of data. If you wanted to do manual things, or once you think about, like, if a single person is creating, let's say, 400, 500 MBs of data, in totality, humanity would be creating exabytes of data per day. And even if you are dealing with a very small use case, very, very small use case, still, this data is going to be massive. So to design these systems manualistically or by using manual techniques, this is not going to work out. Okay. So here we require machines to help us. And this is where machine learning comes in really, really handy. Okay. And of course, we want to speed up innovation and analytics all across us. Okay. And then we want to make more sense of the chaotic world around us, because so many things are unknown to us, or we are not able to understand, or we are not able to appreciate, and we are not able to predict. Like even within COVID, I think it was a perfect example that if you are not able to predict what's going to happen in next 3 months, 6 months, the cost is going to go up. Like COVID put a tremendous strain on our supply chain, and that through our cost. And you can see inflation has gone up across all over the world right now. And slowly, hopefully it will come down. Slowly, it will come down, no doubt. But if you cannot predict how much would be the demand after 3 months, 6 months, it affects production, it affects supply chain and everything that comes. Okay. So that is really interesting if you think about it. Okay. And of course, as I told you, the biggest reason is data itself here, that the amount of data you end up creating every day, okay, that has caused this massive upheaval. So guys, has any one of you worked or heard about big data? Not just, Ibrahim, it's just not the organizational part. It can figure out patterns throughout the data, and based on that, it starts making predictions. Okay, so some people are saying they have heard about big data. So guys, how would you define big data if I ask you? Largest number of data sets. Okay, okay. So how do you, what is the number for you? Like if I were to really ask you?
லேப்டாப் எடுத்துக்கிட்டு வந்துறது அந்த தெரியாது எனக்கு அப்படின்னு எதுக்கு வரேன்னு.
Not just CSV file. CSV is not the only problem here, guys. CSV is not the only issue. Okay. We are interested in how much. Okay, there are multiple factors why something is called big data. Okay. So as you already know, or as you might have already have understood this part, that we create new data in amounts of petabytes every day through our calls, SMSs, chats, selfies, videos, emails, and whatnot, right? We do this again and again and again. We have increasing computational power. So as you might know, every year or every couple of years, whenever you buy a new mobile phone or a computer, iPad, or any machine, even TVs, your smart TVs, they have starting to have far more computational power than ever. Okay. And with faster CPU and GPU cores, much faster CPU and GPU cores every couple of years is just impressive. It's just increasing, and that's impressive. Okay. And of course, this field of machine learning is extremely mathematical. So there has been increasing collaboration among academia. So a lot of professors are kind of now working with academia, and like professionals are kind of working together to come up with very complex solutions that are required to solve these problems. Okay. Similarly, and if you can predict what's going to happen, how the demand and supply is going to change, like a lot of these days, we have so many online sales that are happening for us, right? A lot of online sales are kind of going in a direction where they are kind of pushing us what to buy, when to buy. Okay. So they of course are trying to predict, okay, and then there are recommendation systems all across us, all around us, that if you buy a t-shirt, they will start predicting or asking or recommending you far many things, right? So that is what's fundamentally happening. Okay. This great infographic that I have here that kind of represents the 4 V's of big data. The 4 V's of big data, or basically how you identify your use case is big data centric or not. Okay. The very first thing, as you can very clearly see here, is volume, scale of data. What is the scale of data? Any idea? Scale is literally the number, petabytes, zettabytes, hexabytes, whatever you want to say. Okay, whatever. And every year, every day actually, forget the every year as a matter of fact. Okay, the data will be created, and as you know, more and more people are using internet for the first time. Okay, I'm back, sorry. Okay, so as I was talking about the volume of the data, scale of the data itself. These days, it is estimated that 2.5 quintillion bytes, that means 2.3 trillion gigabytes data is getting created. So that's like massive amount of data that we are creating every day. Okay. And as I told you, like most population has gotten, let's say, the internet connection within like last 5 to 7 years, as a matter of fact. And this sheer volume of data that we are talking is definitely one of the very first properties that we'll look at when we talk about big data. Yeah, Moore's law has been there. Like it basically said that every 18 months, okay, almost every 17 to 18 months, the amount of transistors per inch square of silicon basically doubles. That's called Moore's law of computation. And this is how it has been kind of following for quite some time, although it has been flattening around recently, but we never know. It might, again, there might be some new innovation, and we kind of keep following that. Okay. So yes, computation is also increasing, no doubt about it, but data is increasing at a much bigger pace right now. Rather than computation, data has increased at a much faster pace in these days. Okay, first is volume. Definitely, that's very important. The second one is equally important, according to me, is called velocity. Now, what is velocity? Velocity is how fast the data is transacting. Okay. So like New York Stock Exchange captures like close to 1 TB of trade information in each session. Yeah, very, very fast. Yes. Modern cars have like close to 100 sensors, and they are measuring everything per second basis. Okay. And of course, you know that most people, what they are using fast internet, broadbands, 4G, and now recently, even in India, we had the 5G spectrum bidding. I hope you know that. I think this week itself, this week itself, we had 5G spectrum bidding. So the spectrums have been sold by government, and maybe 6 to 8 months down the line, we'll start seeing the full-fledged 5G rollout throughout the country. Of course, it will happen in phases. First, tier 1 cities will get it, tier 2, tier 3, so on. More and more cities will start to get 5G, right? So that will happen. Okay, so that's velocity, and that's again a big problem, and that's one property or marker of big data. Then we have variety. What is variety fundamentally? Variety is the data that you are creating is of different kinds. Now, YouTube data is different. It is different from what your SAS data is. Yes, very good, Manali. And then you have different variables, wireless health monitors. All of these are of different kinds, different types of data that they are generating. The data that is being generated through Facebook is slightly different than what Twitter might be generating, what TikTok might be generating. Yes, we have video, images, text, JSON files, database files, right? Semi-structured, unstructured, semi-structured files. Yes, very good, very good. So yes, when we talk about big data, we have to think about variety of the data. Reviews is text data. Yes, reviews are there, but any kind of NLP or text data is reviews will fall under that. Okay, and then the final one, which is actually the problematic one. Look, all four can be problematic for us, but this final one we have to think about very carefully. The final one is fundamentally saying is veracity. Okay, what does veracity means? Veracity means we do not trust that information, basically. Okay, poor data quality. Yeah, go ahead. Were you answering?
Truthfulness. Truthfulness.
Yeah. Here we do not have the truthfulness of it. You can say that. Yes, you're correct. So veracity means we do not trust the information, that maybe the sampling method, the way it has been collected, is wrong. Maybe the data quality is poor. Maybe the data has not been formatted properly, or maybe the survey results or something that you collected are extremely biased. Multiple reasons could be there. Okay, it's just not the one. There could be multiple reasons that could be causing this issue. Okay. So veracity is a big problem, that even if we have large data, but what if it is not reliable? We'll not be able to use it. And this is where one serious problem is there, no doubt about it. But I would like to say, even if these are problems, we are trying to solve these problems, particularly with help of data science and machine learning. Okay, so that is what we are trying to do. Okay. Now, again, if we try to talk about concept of learning in machine learning, and I think I gave this example already, that even if you have all this, Let's say if you have a task that you want to make better route decisions, and performance measure, you will have to define some kind of performance measure. And let's say performance measure is to make better route decisions. Okay. And that will be a really important thing to kind of figure out. And we could have our experiences that we will like to travel through different routes and times. So that would be really interesting. And if the system is learning, it should start making decisions about selecting routes as it experiences more routes and time associated over there. Okay, so this is what machine learning is all about. And like this is a very classical problem statement that one could discuss about and one could think about as well. Here, what we are thinking is, this is like a classic example of object detection, that there is an image given to us. Now, within that image, you want to figure out different objects. Okay, let's say a kite, a person, okay, or maybe the dog, okay, or maybe a home, right? So we want to figure out these different kind of image objects. And this is a very classic machine learning problem that based on the pixel information that we have been given, we want to output the coordinates of the pixels. We want to figure out what is the gonna be or where the object is. We want to know where the connectivities are and how they are connected, labels of classes and their percentage confidence, whatever we can get over there. All of that is required. And if the system is actually learning, so if the algorithm that you have designed is actually learning correctly, then it should return correct classes with the closest coordinates. So what I'm trying to say is, if there is actually an object over there, okay, let me draw something. If there is actually an object over there, okay. And if the detection has really worked well over there, then what should happen is, we should be able to draw the tightest bounding box as much as possible. And based on that tightest bounding box, we should be able to tell what this bounding box contains and how or what our ideal outcome would be. Is that okay? Yes, OpenCV is one tool. Okay, OpenCV is one tool, although we do use a lot of deep learning methods right now. So OpenCV is very good for processing images and videos. And OpenCV does has a lot of really good models as well with it. But the better way also would be to use like a lot of deep learning models that we can devise ourselves for. We can use some kind of pre-trained model. Okay. Okay. All right. Very good. Now, the problem is there are challenges. It's not that straightforward. Okay. So here in these challenges, we have to create systems which perform with accuracy and precision of human intelligence, and then we can leverage machines innate architecture to accelerate and keep up with big data, right? Scales of terabytes and petabytes of data, because machines are inherently faster, okay? In terms of sheer computation, machines are much faster than humans. So basically, it allows for faster and better decision making through machines wherever possible. That is what the intention is. And of course, we want to convert large amount of raw data into useful analytics. So to help forecast the future trends and correct our estimates based on analytic output. So whatever we are learning, we want to correct our estimates beforehand. And correcting these estimates beforehand is really gonna be important for us. Because if we get the correct estimates, we can make the predictions very upfront. And these upfront predictions can help us save a lot of amount of money and will also be incredibly useful to plan ahead. Get up with the right inventory well in advance. Okay, 1 minute. Guys, I will give you 5 to 10 minutes for general discussion. Don't worry. Let me just talk about this topic, and then I will go deeper with your questions as well. Okay. Okay. Now, before we go even a little deeper and have some discussion, there are certain terminology that one should know. The very first one is called population. Population is any specific collection of object of interest. Any topic, any complete class. Let's say you say Hyundai cars. Okay. The population would be all the Hyundai cars. Okay, that have been, let's say, manufactured. Now, sample is a subset of the population. Okay, sample is a subset of the population. What is measurement? Measurement is a number or attribute computed for each member of population or of a sample itself. Okay, and the parameters or the feature is a numerical value that summarizes some aspect of the whole population. So let's say we are talking about dogs. So dogs would have weight, they will have height, they will have breed, right? So all of that is there. Inference is like any key knowledge about data sample or a population that we derive from data analysis or statistical inferences that we come to know what is going to be the outcome. So that is something that is interesting to us. Okay. Like, let's talk about this apple. So you see this apple here, right? So guys, what are the attributes or features associated with this apple? So when I tell you about apple, what do you think about it? Color, texture, color, shape. Some people might think about the price. Is it sweet, right? It's a type, what kind of type it has. Yes, taste is there. Yes, very good. Yes, hybrid, organic. Yes, that's another term that we definitely think about. Very nice. Size is one thing. Yes, import type. Yes, yes, very good. So yeah, guys, these are called features of the class, okay, that we are trying to study. Okay. Okay, guys, before I go into types of machine learning, why don't we take 10 minutes in between where I kind of answer your general questions. So you guys can start asking questions. I will read out in the chat and I will try to answer them. So guys, I think we can go ahead and Ritik, will you give glance? I'm not getting that question. Would you like to elaborate on that question? No, we are going to have 10 minutes right now. And even at the end of the session, we'll have this time. So let's have a general discussion. Okay. So because I know a lot of you must have some questions. So I want to answer those questions to you as well. So guys, if you have any questions, feel free to ask. And let me answer them as well right now. Pratik, so you can ask Learnbay to, this session is getting recorded. So you can ask them for this recording. So it is up to them if they want to share. Okay. Ritik, you can write the question right in the chat. I will read out your question. Guys, everyone, if you have any questions right now, this is, let's say, have an open discussion right now. Just write your question in the chat. I am looking at the chat right now. So I will start answering your questions. I will read out your question and then I will give you the answer. Go ahead. Pratiksha, so you can reach out to Learnbay for this, okay? And they will be able to provide you with this recording, okay? So you can go to our Learnbay page on LinkedIn as well. And over there, you can contact Kavya or Karishma, and they will be able to help you, okay? Okay, go, guys. Any other question here that you guys might have?
Sir, sorry I'm late.
What's happening here? Okay. Okay, so the question is how to increase the accuracy after building models. So now there are multiple ways. Once, first we will have to figure out, are you even using the. So then after we have sold off our existing product, we let go of 7 people. And right now we are only working 5 people. But once we come up with our product prototype, we'll end up hiring 10 to 12 more people very fast, as a matter of fact. So at one time when we were developing Deep Interview, we actually had 12 people and 7 out of them were working in the fields of artificial intelligence, deep learning, and machine learning. So for let me answer the Rahul Lekkar's question, that how to increase accuracy after building model. So guys, if you build model, like first you have to compare it with multiple models. There is no just one model that works. So for most problem statements, you will have multiple models that could be candidates. So my advice is always to compare multiple models. Make sure you tune their hyperparameters as well. Try it with different data sets and try it also on try to reduce the data set or try to cut down on some data set and check if the performance remains the same. Do some cross validation. Okay, so usually hyperparameter cross validation would really be helpful for you to increase the accuracy. If you have some kind of class imbalance problem, you might have to balance the classes. So for this, like a smart or ADASIN can be incredibly useful. Okay, Pratiksha says, what are the guidelines for beginners to learn machine learning artificial? Pratiksha, at the end of this slide, I'm going to talk about that. So if you can just wait for that, it would be really helpful. In this slide itself, we are going to talk about it. Then, so 3 people are in Bangalore, whom I meet regularly. 1 person is working in a remote setup. Ritik says, I'm studying BTech in IT, sir, but I want a machine learning. Okay. So Ritik, I think you are already very well placed. First, learn some programming language like Python. Then focus on statistics and machine learning and deep learning. And then start doing or developing some end-to-end projects where you start with a problem statement, take different kind of data sets, develop an end-to-end solution and try to deploy it. And based on that, you start applying to different companies who have similar roles. So I think you are very uniquely placed right now that you already are in the right field, according to me. Just need to put some more effort around machine learning and data science. I mean, I will say that you can try to build a scheduler, like I think a meeting scheduler, if you can build on Python, you will get a lot of exposure to understand how Python works. Okay, if you can build a meeting scheduler, or even if you can build a small server with Python using Flask, where you can integrate different meeting schedules and send out notifications via email. So any kind of end-to-end project that if you try to do, gives you a lot of good exposure. Ritik, it depends on your financial scenarios and your aspirations in life. I will not say that for becoming data science masters or PhD is required. Okay. But understand that if you really want to take a deep dive, a significant amount of time has to be spent. And if you like to study in an ordered manner with a proper curriculum and everything, then yes, taking some online course or actually going for a master's would actually help you out. It depends personally. A lot of people can do a self-study on their own. If you are those kind of people, there are online resources which are free, which you can follow. Okay. Rahul, I cannot answer that question here because we are not going into the pandas and everything. Okay. But yeah, it's a straight up function that we use for iLog, and over there it's just a matter of using the so depending how many arrays you have, if you have only 2 dimensions, x is the 0th axis and basically, or you can say that rows are 0th axis and Y is the one axis, axis number one. Accordingly, you can manipulate the ilog. Okay, guys, any other question? Yeah, Ritik, that's why I'm telling you, if you're determined, then go for it. It's a really great field and financially rewarding as well. Like if you actually make it big, then there's a lot of big money to be made here. Okay. So if you are really determined, then you have to put some serious time. Like 1 year should be the minimum here for you, at least that 1 year effort will take to learn statistics, machine learning, deep learning, do various kinds of project, master them. It takes time, but yes, definitely it will happen. Okay, no other question? Depends where are you doing, and like in India, there are like a lot of institutes, and like even Learnbay is one of them where you can do this. So it depends which institute you're gonna go to. Yes, cost could be high. Doing masters could cost you 6 to 8 lakh rupees in 2 years. So again, it varies place to place. I cannot give you a guarantee, and I did not do masters in India anyway, so I cannot talk much about that anyways. Okay. Okay. Okay, guys, let's do one thing. Let's take a 5-minute break. I will have some water. You guys should also have some water. And then we are going to continue with and try to finish the idea of machine learning. And then we will talk about a little bit about Python. Okay. Okay. Okay, guys, just taking it a small water break, and I'll be back within 5 minutes. Okay. All right. Okay, guys. So now we are going to continue off where we left off. All right. Am I audible here again? Okay. All right. So guys, when we think about machine learning, we have to think there would be different use cases, okay, and different kind of machine learnings. And inherently, I could differentiate machine learning overall in 3 major domains. Okay, one is called supervised learning, where we do provide the output labels and tags with the input data. So while training the machine learning model, we do tell machine learning what was the outcome. Okay. And that is the biggest field. That is where the most of the success has been found, according to me, so far. Now, over there, it could define or it could work in a form of regression / prediction. Okay. A lot of different stuff could be given over there, right? Now, that could be one thing. Maybe we will deal with classification. Then maybe it is unsupervised learning that no output labels are given over there. And just through mathematical properties such as distance based on density or distance in a hierarchical fashion, we would have to decide how to group them together. Then we also have something called reinforcement learning, which works on a reward policy feedback system. Okay, so this is not going to be a traditional machine learning or looking like machine learning. It would be slightly different for it. Okay, so over there, we would be able to come up with ideas on reinforcement, which works on reward policy. So basically, you tell that you want to maximize some reward. Okay, and we design algorithms like that where we are able to get it better. Okay. So in supervised learning, what happens is you have been given your raw data. Okay. You have been given your raw data at that point. One moment, please. And in this raw data, one step you will see is you have this raw data, but you have human here, right? Supervisor. Or like rather than saying supervisor, we should say some data labeler. Someone is trying to label the data at that point. And this is an important step. Okay, this is the important step in a supervised learning, that if there is no one to label the data, if there is no one to label the data, we will not be able to run machine learning algorithms at all. Okay. So that is there. Then you have algorithms, then you process and you segregate it in different classes. But putting these humans here can be incredibly costly. And as you have large amount of data, it ends up costing you. It ends up costing you a lot to put these humans over there to keep annotating data. Okay. So this is your supervised learning. Okay. And then we have the other one, which we like to call unsupervised learning. Now, what is unsupervised learning? Now you have in unlabeled data here. In unsupervised learning, we have the unlabeled data. Okay, where we do not have the right labels, or we don't have any labels, not right labels, any labels. And we have our input raw data. And based on the mathematical values, their nearness or their density, the algorithm tries to decide how to cluster them or how to group them together. But understand, and this is important, the accuracy or the efficacy of unsupervised techniques is nowhere close to the supervised techniques. So still, I think a lot of research needs to happen in the unsupervised field, or a lot of people have started calling it self-supervised, okay, rather than calling it unsupervised, that you have some policy which is self-supervising the overall structure. And then you have your reinforcement learning, right? You have, let's say there is a rat and this rat is left in a puzzle, okay, or maze. And there is a cheese box or cheese over there somewhere in the overall environment. And they have to figure this one out, or they have to get the basic outcome, or they have to understand where is the cheese exactly put over there. So based on their distance, based on the smell, the rat would try to navigate the maze and would try to get the cheese to eat. So here, the bot or the software is basically taught or takes an action in an environment so that it can maximize some notion of cumulative reward, and it keeps on updating a state in order to get the maximum reward in the given amount of time. That is called reinforcement learning. Now, reinforcement learning is mathematically a little harder than simple supervised and unsupervised, but something there where a lot of research, advanced AI research is going on right now. And that is something that if someone is interested, should definitely have a look at. Okay. So this is, I think, a very good idea, or I think according to me, it would be like a very good scenario that one needs to understand and one needs to work about. Okay. Okay, let's go. And this is the basic idea of supervised learning, that when we are talking about supervised learning, we have these different classes. Okay, the classes you can clearly see in different kind of shape here, right? You can see the shape itself is different. So basically the algorithm is known, or algorithm is let know what is going to be the outcome. Okay, so we tell the algorithm what's going to be the outcome over there. In unsupervised learning, we do not tell the algorithm that there are different classes or something. Just based on mathematical properties, as I told you, like distance or some kind of nearness factor or density, it is able to figure it out. Koina, there is no operand answer here. Okay, different algorithms, both in supervised and unsupervised methods are present, and some of them would be faster for supervised and some will be really slow. So there is a host of learning techniques which work, and both can be slow or fast depending on which algorithm you ended up selecting. Is that okay? Okay, very good. Yeah, Koina, yes, it can. Yes, depending on how much labeling we have to do. Yes, it could take a lot of time. Okay. It could take a lot of time to get all these outcomes. Yeah, Manali, that's the idea. That similar data based on some distant metric is something that we try to get. Yeah, it could be based on distance, it could be based on density as well. Like in one area, how many number of points are there, right? So yes, based on this, we can have this. All right. Any other answer? Any other questions? Sorry. Even within, and tomorrow I'm going to talk about regression a little bit. So I'm going to give you some examples tomorrow. So regression could be a simple idea where we refers to the correlation between dependent and independent variables. Okay. So regression would be an idea where, let's say X is the independent variable, and based on the X, let's say Y is decided. And let's say some coefficients are involved over there. And based on that outcome, we get our final outcome. So the problem is, how do we determine the right coefficients? So in a statistical, regression is defined as a measure of relationship between the mean value of one variable output to the corresponding value of other variables, that is the time and the cost. Okay, so accordingly, regression, which is an extremely supervised example, that's how it works. Okay, that's how the idea of this regression works at the end of the day. And this is where, let's say Y is also numerical. Okay, Y is numerical, X is numerical, and we try to predict some constant outcome or some consistent outcome. The overall core idea is that, let's say, okay, let me give you a simple example. Guys, let's say if this is how the data is, and yes, there would be some randomness in the data. So could you tell me how the outcomes would be decided? Or let's say if something is given till, let's say, n is equal to 10. And if I were to ask you now, what about n is equal to 15? What would be the outcome? What your answer would be? So this, again, you have to kind of extrapolate based on the function estimation that you might do. I think that's like kind of a small assumption that we have made, that we are dealing in a linear function or linear manifold scenario. Okay, so when we do with linear manifold, we have to start with some kind of equation of line. And so here maybe someone can say, maybe you need to determine the function properly based on the data. And based on that function, then in future, you will be able to make a future prediction. Okay, that on some, let's say n is equal to 15 days, what would be the outcome over there? Now, and then it doesn't always have to be even line. It could be some nonlinear function very easily. Okay, so yes, line is a good starting example, but you could have a complex function over there as well, and which you might want to extend to understand what is going to happen in the future or for some new unseen data point, right? Okay. Okay. All right. Any question here? Yeah, Goena, that will be an issue, although I think that is a too advanced discussion right now, that what is underfitting and what is overfitting, how to decide on that. But yes, you are absolutely right. We have to figure out some way that we have to have some kind of a description or some kind of a like a discrimination, like where we can establish underfitting and overfitting, and we have to tell that. Yeah, Pratiksha, in a lot of temperature experiments, we do use regression itself, but not all weather predictions are just regression, but temperature and humidity predictions are regression examples. Okay. So this again, as I told you, maybe it doesn't always has to be a line or a linear system. You can clearly see that if the data is non-linear, we might have to fit in non-linear system across it, and that is basically what we call like to as regression. The core idea is to predict the points in future, and we assume the data distribution will hold up even in the future, and new points will be near around the function itself. Is that okay? Okay, very good. Let's move on. There is some. And then similarly, okay, so if someone wants to know what could be regression, sales prediction is one, or price prediction or product pricing, expense overrun variables, house pricing prediction, population estimates are a very good example of regression, pollution particle estimates that if you're running your vehicle for hours or if you're driving in different environments, what would be the outcome over there? Okay. So honestly, regression will find its uses anywhere we want to find correlation as well. So like temperature, like room temperature or something like atmospheric temperature versus the number of cones sold at ice cream store, right? There could be a lot of examples. Inches of rains versus new cars sold. Daily snowfall versus new number of scared visits. Okay. And then you can equally have a classification. You can equally have a classification here where we could have a scenario where we want to segregate groups, okay? So maybe one class or the other class both have to be segregated by a line, a hyperplane or a curve, as you can clearly see, in order to achieve the good classification that we have over there. And they should be segregated well. Okay. Logistic regression, decision trees, support vector machines are an excellent example. This example is particularly from the support vector machine itself. And here you can see that line or hyperplane, the red one, is kind of segregated. Due to that hyperplane or the curve, whatever you're observing is getting segregated here. And these two classifications or two classes are totally separated out. And that is what you want. Again, it doesn't have to be hyperplane. It could be a complex curve, which might be segregating. And again, overfitting and underfitting would be an issue. But again, in these examples, as you can very clearly see, you have some supervised data. You have some labels well-defined, pre-given, and based on that, we train our algorithm. Okay, let me show you. And there are different use cases of classification, such as spam filtering itself, cancer diagnosis, text classification, sentiment analysis, object classification, we have face detection and whatnot. So similarly to regression, this technique can be generalized into any problem where we know there are discrete classes. Classification of people based on their eating habits like vegetarian, vegan, non-vegetarian, and whatnot. Okay. So all of this can happen and this could work very well over here, right? Now, some people ask what is required. So I told you like we will discuss this part, okay? So guys, let me tell you what will be required. First, generically, you will need to have a good intuition about problem solving, okay? Okay, so if you are good at problem solving, this will definitely work out. And linear programming would be, then you have to learn some programming language. Like Python, R, Java. Okay, but Python is definitely one of the most used languages right now. And this is why we also kind of tell people to look into Python programming itself. No, R is not mandatory. Either of these three languages, as I told you, Python, R, or Java. You can learn either of the three languages. There are multiple languages, but just make sure you focus on one language particularly. Then you have to learn some linear algebra basics like matrix multiplication, matrix operations. You will need to have some familiarity with data preprocessing techniques. Okay, data cleaning and a lot of these methods, you will have to have some familiarity here. You need to have a keen focus on learning new tools. You have to understand this field is expanding rapidly right now. And it has been happening for quite a few years now. So there are always some new tools that are coming in this field, and one needs to be on their feet. You need to also learn like machine learning, deep learning, SQL, NLP. There are just so many new concepts that has to be covered. So I think Python is one of the best languages that's available for machine learning. I think R and Python are very neck to neck, if you ask me. You need to have, you should enjoy solving problems from different domains as well. And you need to have some aptitude to imagine and implement. There is a lot of implementation at the code level. And if you're good with coding, it will definitely help you out. Okay. Anyways, if you have any question, do let me know here. Okay. And it's an everyday process. You cannot think that we will be able to learn this in 3 days or 3 weeks or 3 months even. It might take a whole year, and still you have to keep practicing every day. Every day you have to keep practicing. So that will be something that's really important. Now, actually, because some people ask this, that what language to use, so why don't I discuss that actually a little bit? Yeah, data preprocessing. Some things are like taking big data from databases, Hadoop, Delta lakes, and data lakes as well. Okay. So guys, let me introduce you to Python today. How many of you already know what is Python? Not the snake. I'm not talking about the snake, by the way. Okay, so Python is a programming language. Okay. Yes, some people know this. Okay. But I think we are not even talking about Colab or Jupyter Notebook. They are the platforms on which we run Python. Python is the language. Okay, so Colab and Jupyter Notebooks are not language. You have to understand this. Okay, some people have basic knowledge, can code a little. That's actually good. So guys, Python is one of the, according to me, simplest languages to learn right now. It follows your objectives, like it does follows functional programming, but it also follows completely object-oriented programming if you wanted to. Now you have to understand Python is a scripting language. It's not a code programming language. So let me explain what do I really mean by this. So imagine you have your hardware, let's say you have your CPU, you have your RAM, right? So each OS has its own kernel, okay? Each OS has its own kernel, okay? And the kernel is written in, let's say, C++ or C language, okay? C, mostly let's say C language, okay? Let's not say C++. So let's say it's written in your C language. And through the kernel, everything is interfaced at a hardware level, everything, okay? Now, on the top of this kernel, you have your OS on which everything is loaded. So if you are writing something close to like C or C++, you can interface with kernel if you want to. You can interface with the kernel layer. But the thing is, writing C, C++ code is not going to be easy. Okay, not for everyone. It's not going to be easy for everyone to write a C, C++ code. It has a lot of different constraints. Okay, a lot of different constraints. And it might take time. Now, if you already know C, C++, then it's good. But if you do not, if you want to do data science where there is a lot of data pre-processing and a lot of complex functions to be written and implemented, I would advise actually work on top of this C layer, okay? The C, C++ language layer, work on top of it. So Python definitely has its roots in C, C++. And these are your scripting languages. This is called a scripting language, okay? Now you can write very complex code in Python. I'm not denying it, but Python is particularly very good, especially amazing language if you think about when you had to write or get things done quickly with less hassle. Okay, so this is where Python will really shine. And tomorrow I'm going to show you a few examples in Python, and I will show you 1 or 2 machine learning examples as well. Okay. Yes, technically you can do data science using C, C++. Gonna be a little complex, okay? Not a lot of libraries are available. And why it became so popular, Python became so very popular because when data science and a lot of new deep learning and machine learning, especially deep learning techniques were developed, most of them got kind of developed around Python, and Python saw a pretty good surge around from 2010 onwards in industry. Okay, so guys, once you have like large amount of data, and in deep learning, that's one of the biggest issues, or the way we like to think is, okay, that we have a lot of data. We have lot of data at the end of the day. And we do not want to get bogged by memory management and error handling and maybe garbage collection all the time. Maybe we don't want that. We don't want all of that at the end of the day. Okay, so we need to be careful here. We need to be really, really careful here. So here, Python comes in really handy to us because in Python, if we want to write some code, it's gonna be really simple, straightforward. And the syntactical errors or the syntax problems are slightly lesser than compared to other languages like C, C++, Java, C#. Okay, and the coding structure is also very simple. So one thing I could advise you today is, for today, if you want to work, and so I would say you can install the basic Python, or my advice will be, if you really want to go deep with, okay, data science particularly, then I would ask you to look into Anaconda distribution. Anaconda distribution doesn't contains Python. It has Python by default, okay, but it contains so many other libraries, and you can see they have like close to 600 MB. So I remember when in 2012, 13, I started learning data science and machine learning. Anaconda installation used to be like around 300 MB. Okay, no, 250 MB, something like that. Slowly and slowly, they are including all kinds of major packages used in data science, machine learning, and even computer vision. Some packages are pre-included right now. And due to that, the size has really increased right now. So if you guys are interested, I could give you this link. Okay, I could give you this link. You guys could go in this link and try to download the Anaconda and just do a basic setup. Okay, just do a basic setup in your computer. And you guys can utilize Anaconda for all these purposes as a matter of fact. Okay. And again, Anaconda can be installed on your Linux, it can be installed on your Windows, okay, and on Mac as well. So any installation, any version that you want is available. And I would really implore everyone, I have been working on Anaconda for like what, 8 years, more than 8 years now, consistently. So Anaconda has like never failed me. If you really ask me, any kind of Python installation issue or Python work issue has always been kind of very easy to navigate with Anaconda. So Anaconda already contains Python version, so you do not have to worry about installing Python separately. So if you have never separately utilized Anaconda, I think this would be a really good time. I think this would be a really, really good time to write or work with Anaconda code. Okay. Now, Anaconda is again collection of libraries. It's a collection of some platforms like Jupyter Notebooks, Spider IDE. Okay. But it gives you amazing platform around Python itself. All right. So, okay. If you have any questions, please go ahead. Okay. Now, within Python itself, Python basics are required, but 3 libraries, according to me, are really important. Okay. The first one is called Numpy. Numpy is this numerical Python. Okay. This is like the fundamental package for scientific computing with Python. Amongst other things, it contains powerful n-dimensional array objects. It has a sophisticated broadcasting functions, and it can be integrated with C, C++, and Fortran code as well. Okay. So, and plus a lot of useful linear algebra, Fourier transform, and random number capabilities are there, which we will have to utilize for data science. No, so then Conda is, or Anaconda is a kind of a set of libraries. PyCharm is more or less, how do I say, an IDE. So you can configure Anaconda with PyCharm. You can configure your Anaconda with VS Code. Okay, so Anaconda is kind of providing you this, although Anaconda does come with Jupyter Notebook and Spider. But if you are using, I think, PyCharm or VS Code ID, you do not need to use Spider or Jupyter anymore. So Anaconda will provide you all kinds of useful libraries that comes pre-installed. Otherwise, you will have to separately install each of them. Okay. Okay. All right. So Numpy is one library that we use in data science and machine learning all the time. And the second library, which is really famous, is called Pandas. Okay. Pandas is this library which is utilized for high performance, easy to use data structure. So you can, so Numpy is very good with numbers, okay, numerical data. But if you have different kind of date time data, object data, string data, okay, and numerical data, of course. If you have a combination of these objects and you want to combine all these things together and want to work together, I think Pandas is the right library in Python to utilize at the end of the day. Okay, and the third one is the plotting library, Matplotlib. Although again, guys, there are tens of plotting libraries available, but Matplotlib is one of the very basic libraries available right now. So Matplotlib is a Python 2D plotting library which produces publication quality figures in a variety of hard copy formats. Okay, so Matplotlib is something like open source, openly available to us, and extremely easy to work with. Okay, across all platforms, you can install Matplotlib across all platforms, and this will work perfectly fine. Okay. So guys, tomorrow the plan is to showcase some examples to you. Okay, showcase some examples to you around Python and some simple machine learning examples. Now, I know you will not, if people who do not know Python might not be able to understand all of these ideas. Okay. So don't worry about that. We'll give you this these ideas. Okay. Yeah, pandas can easily work with date type. Do not worry about that. Yeah, it will also display you data of different kind. No, Matplotlib is a separate Python library. It has nothing to do with MATLAB. MATLAB is a separate language, guys. MATLAB has nothing to do with Python at all. Okay. So guys, if you have any questions, I think, no, they are not the same concepts. MATLAB is a complete tool. Matplotlib is just the plotting library. Okay, guys, so would you do me a favor and install Anaconda if you want to learn? So tomorrow I'm going to show you a few examples, okay? How we run machine learning, how we can run some basic code in Python. Again, within 2 hours, of course, I cannot teach you Python. That's not going to happen. So I will just give you some examples, give you a feel of the examples, like how machine learning will feel like. And then you can decide what to do about this. Now, the final thing is, guys, we here at Learnbay do provide you excellent quality courses. So I will really encourage you, if anyone is interested in data science or artificial intelligence fields, I think you guys should definitely apply for counseling, or you should start putting an inquiry here. And if you are interested, I think this should be amazing course and maybe an amazing opportunity to move forward. Same timing, 1 to 3 p.m. Okay. Pratiksha, I think in different fields. So recently, one of my mentees, she kind of told me she has gotten a job in as a senior data scientist in a petrochemical. Okay, I know a lot of senior data scientist friends who are in banking, finance, insurance industry. Our product was more around hiring space, like interview process. Okay, and then there are a lot of AI use cases right now going across manufacturing industry. So different industries are adopting the specializations of AI and ML right now. Oh, amazing question, Rav Kumar. I hope you are having some good learning here. Okay, good. All right. Okay, so tomorrow again, I'm gonna, oh, you are yet to start. Okay, but I hope, I wish you all the best, by the way, in meantime. So I hope you have a great learning experience. Then, so how big a practical part in ML course? So then, like, you have to understand, I think I will say 60 to 70% part should be definitely practical, where you have to code, you have to explore data sets, you have to work on the actual problems. 30% could be theoretical if you want to put some kind of numbers. Koina, I think you will need to talk to the consulate. They do provide some internships, but I'm not the expert in that domain. Again, Ms. Alia, I think you will have to talk to Learnbay. So you can go to our posters on LinkedIn, and you can contact Kavya or Karishma over there, and they can only talk to you about the this thing. I cannot talk about all that. Ritik, no, I think for ML interviews, especially because you are in college itself, you will need to work very hard to get some secure some internship if possible, or showcase some kind of real-time example with machine learning. That will help you with interviews. Just having a course is usually never good enough, because you have to understand India is a large country. There's a lot of population, and there are a lot of people learning data science as we speak. So how would you differentiate yourself? You have to put up some differentiation in your favor. So some kind of work experience, some kind of actual project, real-time project with actual data, or even simulated data is fine. I'm not saying it has to be exactly per se, exact actual data, but these things will definitely help you, and specifically once you are able to work around with all this. Okay. Okay, any other question? Monali, so in data engineer, it is more about data handling, data cleaning, okay? So again, there would be some data analytics over there as well, but data engineer is mostly programming, where you are kind of working and kind of trying to solve different problems where you are getting multitudes of data and you are cleaning them up, making them ready for data science use. Okay, and Karishma is giving some links here. So I guess these will be helpful for you guys as well for getting more information about our hackathons. So please join our Telegram channel as well. Monali, I think both have, depending on what kind of work you guys are doing at the end of the day. In both fields, you will have to have code a lot, even in core data science field as a data engineer. Both are programming heavy. Now, I have never counted the number of codes or something, so I cannot tell you exactly how much has the coding here, but both will require you to be good with the coding. Okay. All right. Any other question? When you are an AI or ML engineer, at the end of the day, you are working in artificial ML roles fundamentally, and you are trying to deploy multiple machine learning and AI models. Now, guys, there is no always gonna be clear-cut distinction. Different companies will name them differently: AI engineer, ML engineer, or data scientist. So sometimes there is a massive overlap. So you need to talk to the maybe the HRs, or maybe you need to talk to or understand the field, the job description very well over there. That's important. You have to understand. Okay. So it's many times it's just a matter of saying maybe multiple roles in different companies can also mean exactly the same thing. It depends how which company or which team has allocated that resource or how they have thought about that resource. Okay. Ritik, as I told you, it's very similar to being data scientist. Okay. Many times these are just different terminology that people use in industry, but more or less they want you to do the similar work. Okay. Okay, guys. So I think I will see you tomorrow now. Okay. At some projects, ML engineer part of workflow data scientist. Yeah, sometimes then that's what I'm trying to say. Sometimes there is no clarity here. Okay. The whole workflow of data scientists can have ML engineers, or sometimes ML engineers and data scientists are practically doing the same thing. We do projects in our own, or we analyze company projects. So, look, you can do projects on your own, but it would be better if you could work or intern with some company at the earlier stage and showcase that as experiment. I think that usually goes very well. So working with some company or some institute is gonna definitely help you. In ML job, of course, like if you have a proper job, then definitely you are working with a company or a client and you are doing their job, or you are running their model itself. Pratiksha, unfortunately, I'm not gonna remember most companies right now. So you will have to search LinkedIn for this purpose. This is something I cannot help you. No, I cannot say that, Rahul. I have trained a lot of people who have directly become data scientists or ML engineers. It depends what is the aptitude. If you are more of a coder, you should directly aim for trying to become a data engineer or data scientist. Okay. Yes, if you do not get a data science position, yes, working as a data analyst would help you. But I will still say, if you're good with coding, please aim for data scientist. There is a requirement for good data scientists still in market. That has not gone away. But a lot of people are actually not good with data coding or something, and that is where the trouble happens. Yeah, then once our project, again, our POC goes live, or if we get the funding, then definitely we'll start immediately. And we will start hiring, but our hiring process is really tough. So do not think that's going to be easy. But yes, we will be hiring for interns at that point. Okay, guys. All right, guys, I think we ought to stop the session right now. And tomorrow at 1 p.m., we are going to connect again. Tomorrow, I'm going to show you. Yeah, definitely done. So tomorrow, I'm going to show you some examples using Python as well. In meantime, I would really implore you, if you guys want to, please download Anaconda. And maybe tomorrow you can also write some code, at least for people who know some Python. For them, it would be easier. Anyways, good guys, I hope it was a fun session for you guys. You have learned something new. And we are going to continue this webinar tomorrow as well. All right. Okay, guys. You guys have a great day ahead. Take care, and I'll see you tomorrow. Okay. All right. Bye, guys. Take care.